Hello and welcome. On the bench today I have an advantech touch panel computer model TPC650H. This is a microcomputer with a touch panel at the front. This apparently is broken, so we'll try to fix it. Now this little microcomputer belongs to a cinema projector. It's the control panel for the projector itself. It's wired to the projector via Ethernet and it runs Windows XP embedded. There is a little app running, showing lots of control, lots of buttons, and by pushing those buttons, the microcomputer will send Ethernet commands to the projector to do what needs to be done. But for all intent and purposes of this video, this is a microcomputer. I would say is an old microcomputer. This is probably 10-15 years old. It's broken and we need to fix it. So let me thank today's sponsor, PCBWay, and let's see what's wrong with this machine. This microcomputer requires something between 18 and 28 volts, and I have a 24 volts power supply here, which I have wired already into the power input. Now this computer runs the software from this compact flash. It can be extracted by pushing this button. There we go, that is the compact flash, but to be honest, we don't really care about the software, because my understanding is that this computer works when it's cold. And after it's been running for about, 20 minutes, if you try and restart it, it just doesn't start. And my understanding is that it doesn't even try to post, so it sounds like a hardware problem, not a software problem. Let me turn this on and we'll try to replicate the problem and see what happens. Power on, 3, 2, 1, go. So yeah, I do have 24 volts. And this is bipped. It says Intel Atom, where it was like gigabyte of RAM, blah, blah, blah. Okay, too fast. And the little app that is driving the projector is starting. Christie is the brand of the projector, so this is working on a Christie projector. And this seems to be working totally fine. So it's going to take a while and eventually it will get into the touch panel controller software. And the software is loaded, we have some error messages. Of course, the projector is not connected. So this is now trying to talk to the various boards inside the digital projector and it doesn't get any reply. So it's coming up with lots and lots of messages. PIB connection lost. If I remember right, the PIB board is projector intelligence board. It's been a while, so obviously it can't talk to the main board. Hello? Yes, and everything is grayed out, nothing is working, and that's not the point. We don't care about the software, that is not the problem. We are looking at a microcomputer. What is being running is not the point of this video. Now, if I restart this microcomputer right now, and this happens by removing power basically, there's no like turn off, shut down option in here. This is designed somehow to be cycle powered. This should work totally fine. Let's try that. Removing power now, 3, 2, 1, go. Give it 10 seconds. And let's turn it back on. 3, 2, 1, go. And it worked totally fine. It posted straight away and now it's loading back the software. Now, I understand that we need to wait about 15 minutes or something like that for the unit to warm up. And then we'll try to power cycle again and we'll see what happens. 15 minutes later, let's see what happens. Power off, few seconds, and power back on, 3, 2, 1, go. And it's completely dead. It doesn't do anything, it doesn't beep, there's nothing on the screen. But if I let it cool down for, I don't know how long to be honest, eventually will start up straight away. So this is kind of weird, because usually it's the other way around. Usually it's bad capacitors, and when a capacitor is tired and it's cold, it's when it doesn't work at all. But once it's warmed up a bit, it gains a little bit of capacitance, and usually that's enough to make the device working again. But I've never seen a device which stops working once it's warmed up. And also, I didn't really test it too much, but it's not like it crashed or anything. It was still working. But if you power it off and back on again when it's warm, it doesn't work. So this is very weird. Do we still have 24 volts at the power in? Yeah, we still have 24 volts, 24.1. So power is getting onto the board, but something clearly is happening. I didn't really check the current going in. Maybe we can check later. Right now, I think what I want to do is open this unit up and see what's inside. And I guess I'll have to play with hot air and cold spray and see what happens. But first thing first, let's open this up and see how it's made inside. Oh well. All right, we are in, and this is pretty cool. I will eventually remove the heatsink and probably the whole board, but not right now. This connector here is probably the display. I'll have to be careful if I remove it. And these two, one is probably the touch function, and the other one, I don't know. Maybe it's the beeper, because this thing is supposed to have a beeper. Well, I heard the beeper, but I don't see here, unless it's on the other side of the board. This is where 24 volts are going in, and it's 24 volts DC, it's not AC, so it doesn't need rectification. We have a very small fuse, very cute. Then we have what looks like an inductor, and I think this might be an NTC, or maybe it's just a capacitor. I'm not entirely sure. I can see lots of rail generation, I can see lots of MOSFETs. We don't have many capacitors on this board. We only have a couple here and a couple here, unless there's more on the other side, which is very possible. I do see a couple of chips here. These are probably for the serial ports, and I'm not sure whether for the Ethernet and the USB. They might be probably on the other side. I have a feeling this is like the Wimbun chip, the main control chip for all the logistics happening on the board. We have a BIOS battery with the clear RTC jumper here. And we can see the compact flash coming out from this end here. So I have a few places where I can check the voltages, though again I'll have to make sure that this is, I guess I can check in the working situation and non-working situation to try and understand whether it's completely dead, try and trace the voltage where it stops maybe, or whether maybe there's one voltage that is not coming up for whatever reason. One thing I've noticed is that ground is not at the same potential of my negative pin on the input. So this is my ground pin, and this is my negative pin. Negative pin doesn't read anything. And I've noticed that my negative pin is actually wired to my USB port. Yes, the USB port. So I can use the USB port as a reference. So the first thing I want to check is what kind of voltage have we got the battery. We got 2.9, which is on the low side, but it's totally fine. It will need to be replaced, but that is totally fine. Before we start disassembling stuff, I'd like to poke around with the unit working and not working and see what we see. Let's power up. I'm sensing what I think is an inductor just after the 24 volts power in. 3, 2, 1, go. No, clearly not. Do I have 24 volts coming in? Yes. Oh, and this has started. Okay, so this is clearly not what I'm thinking it is. Well, clearly we got 24 volts at the fuse, which is great. And we also have 24 volts across this green component, which I believe it's an NTC. Now, if I'm checking these rails, I got 1.8 on this inductor. I got 5.5 on this one. What is 5.5 for? And 3.3 on this one. This inductor here is 1.5. I have a feeling this might be for RAM. And this inductor here is 0.9. So this maybe is RAM, or maybe it's one of the CPU rail. I don't really know. And finally, we have a 12 volt rail. I'm wondering whether this is for the display. Well, I think the next step would be to recreate the fault, because I believe this is working right now. Yeah, it is working. It's still loading. So maybe I don't want to upset it right now. Let me wait until it's finished loading its software. Actually, I think what I'm going to do next, I'm going to remove the compact flash, number one, because I don't want to damage it. Number two, because we don't care about the compact flash. We don't care about the software. We just care about the computer not posting. So the app has finished loading right now. I'm going to power off, and I'm going to remove my compact flash. So we don't have to worry about it. There we go. Now, let me speed up things. So I'm going to use my hot air station set to something like 100 degrees at a very high airflow. So to warm up this whole thing. And I want to probe again once the unit fails to post. All right, I think I managed to recreate the problem. I got power in, but this is not posting. Let's make sure we got 24 volts coming. Oh, we don't have 24 volts coming in. Do I have 24 volts coming in? No, sorry, I don't have my negative probe connected. So yes, we do have 24 volts. Now let's check those rails again. We got 1.8, we got 5.5, we got 3.3, we got 1.5, we got 0.9, and we got 12 volts. So all the rails are there, but the thing is not posting. That's interesting. Now, I'm curious to see what kind of current we have when the unit is posting and not posting. So I'll open this wire a little bit, and I'm using my current clamp. All right, let's power up. It's been a few minutes since last attempt, so probably will work right now. 3, 2, 1, go. And we got 0.4, but it's not beeping. So I think it's 0.4 and that's it. I don't think it's posting. No, it's completely dead. So when it's not doing anything, we got 0.48, not changing at all. So what I can do now, I can use my cold spray here and try to cool down the whole board, or maybe I'll just use a fan, so to save the gas for later on, and see if I can revive the board temporarily, just to see what kind of current it draws when it's working. Oh, right, it is posting, and it just went to 0.7, so it's not a huge difference. And then I guess probably now it's stuck on the post screen and it's 0.615. Let's take a look. And yes, it's stuck in here, this boot failure, and it's stuck on 0.65. So it's not a huge difference. I was expecting like many amps, but no. So that is, yeah, it tells me something, but not too much. And if I'm not mistaken, it actually starts for a few seconds at the same current, and only when it beeps, then you see it go into 0.6. Let's try this again. 0.4. Yeah, it actually starts drawing a tiny bit more current after the beep. So yeah, probably this is not telling us too much. And I've been poking around with hot air and cold spray for a while. I haven't really found an obvious spot that changes the behavior of the computer once it's been cooled down or warmed up. What seems to be linked to the behavior is the heatsink. If I warm up the whole heatsink, then the thing stops working. If I cool down, well, it's difficult. Obviously, if I'm cooling down the heatsink, I'm probably cooling down the whole computer. Then it starts again. I think it's time to have a look under the heatsink, and this begins to feel something like a BGA problem, which is not my best skill. Let's remove the heatsink and see what's under it. Under the heatsink, we find the south bridge, this large chip here. This should be the node bridge, because this one is the CPU. It says N270, and the Intel N270 is the Intel Atom N270 1.6 gigahertz, which was being shown on during the post-process. So definitely that is our CPU. I'd imagine the RAM is soldered on the other side, so we'll take a look in a moment. Right now, I think I'd like to try and power this up without the heatsink. It's an Atom. I think the Atom can work without heatsink, probably not doing too much, because I'd like to try and run some tests now that the heatsink is removed. 3, 2, 1, go. Is it posting? Yes. Oh well. It's lukewarm. It can definitely work without the heatsink, at least during post. Yeah, everything is very lukewarm. So I can do some tests without the heatsink, which is exactly what I wanted to do. Perfect. Yeah, it's still, I mean, my finger is warmer than the CPU itself. So let me remove these thermal pads, and I'll start playing again with the hot air and cold spray and see if by any chance I can change the behavior of this thing now. Alright, having poked around with hot air and cold spray, it is difficult. As I've learned on the Focusrite sound interface, when you have BGA stuff, they're all connected together through power planes and ground planes, and if you cool down one chip, you can actually feel the heat or the cold reaching the other chip if you keep your finger on it. But by poking around, I have a feeling that the responsible is the north bridge. Please take this with a pinch of salt because of what I've just said. So let me cool down just the north bridge with my cold spray. Give it a few seconds. And I'll power on now. 3, 2, 1, go. And it's posted fine, totally fine. Now what I'm going to do, I'm not even going to use my hot air station, because I've realized that the north bridge is warming up enough to get pretty hot, not untouchable, but just my finger on top is enough to dissipate that heat. So it's just a few watts, it's nothing out of the ordinary, but it will kind of overheat by itself, it will warm up by itself. So I give it like 15 seconds, 30 seconds, until it gets a bit toasty, and then I'll power cycle it, and it shouldn't post. Okay, let's power off now. Let's give it 5-6 seconds, and turn on back now. And it's not posting, perfect. Now I'm powering off now, and I'm going to cool down just the north bridge. I'll try to be careful. Okay, that should be enough. Let's give it a few seconds for the gas to do its magic. And power on, 3, 2, 1, go. There we go, it posted. So once again, take this with a pinch of salt, because I've learned that this is not a definite test. But when I test it with the CPU or the Southbridge, I wouldn't be able to replicate this behavior as clearly as with the Northbridge. So this seems to be suggesting something. BGA. Obviously, this is a BGA package, so the chips, the CPU, the Northbridge and the Southbridge are connected to the PCB via tiny solder balls. And those solder balls, this is post 2000, so these solder balls are lead-free. And lead-free solder balls, they tend to crack over time. We're talking about a decade, but they will eventually crack. They might eventually crack. So that is not great, because it's not a simple solution. It means that we need to either reflow or reball the Northbridge, and I'm not very good at doing that. But before we jump to conclusions, I'd like to see what's behind the board, because you never know if something behind the board that is being triggered by the heat and the cold that I'm spraying on top of the board. If you have a project which requires a PCB, 3D print, sheet metal fabrication or CNC machining, well, PCBWay is definitely your stop. I personally use PCBWay for PCB manufacturing and 3D prints over the years. I've always been extremely impressed by the quality, and the customer service is just top notch. Ordering a PCB is pretty simple, and you can choose the color. As you can see, I like the red PCBs. This is my XT IDE, and this is a new project which you're gonna see very shortly on this channel. For this project I had this little enclosure printed, 3D printed, and it looks absolutely amazing. The quality is very, very nice, very professional. This is going to be an axe soldering station, and placing the order for the PCB and the 3D printed case was very easy on PCBWay.com. For the PCB, I downloaded the Gerber file, uploaded it on PCBWay.com, chose the red color, selected the postal service, and that was it. A very similar process applies to the 3D printed case. You just need to find the STL file for the project and upload it to PCBWay.com. So take a look at PCBWay.com. The link is also down below in the description. It's an affiliated link, so if you purchase something at PCBWay through that link, you're helping the channel. And let me thank PCBWay for sponsoring these videos on my channels, because their help makes these videos possible. So thank you very much, PCBWay. Now let's continue with this microcomputer. Alright, the board is out, and for the life of me, I can't find the beeper on this machine. We have 3 connectors going to the monitor section. This one is clearly the actual LCD, which is going through a little board, LVDS it says, so that's definitely the LCD, and then it goes into the LCD. This one, which is, I believe it's like a USB connection, there's a little connection here. That's probably the touch. I think this is featuring an extra layer that is sensitive to the touch. And this one, I believe, which goes into this board, which has a little trimmer here, and then comes out from here and goes back to something. I think that's the backlight. So this might actually be, I don't know, maybe the 12 volts that we saw before that is going to the backlight. I don't see a beeper here, and I don't see a beeper on the board itself. Now on this side we obviously have the RAM, which is socketed, thankfully. Maybe we can give it a go. I doubt it could be the RAM, but when the board is flexing with heat, maybe the RAM is not happy. I think the board would probably play an error code with the beeps. If the RAM is not there, we can actually check. I can see here a Realtek chip, so that is for the Ethernet port, which happens to be here, so that makes sense. And this one, it's an ICS chip, and I haven't looked online, but usually ICS chips are for clock generation, so that is the one generating the clock of the board. Now, the Northbridge happens to be behind here. There's really not much around here. I guess at some point I'll just put the board under the microscope and make sure there is nothing. If I turn this on, does it beep? Assuming it posts. So I turn it on now. It's beeping. Where on earth is the beeper on this board? I really don't know. Right, I think it's this thing here. It's called, oh yes, SP1. Speaker 1. This is a little beeper. I had never seen anything like this. They usually have a little hole on top. But this is amazing, so I don't need the monitor, because my concern is I'm flipping things around, I've got all the cables connected, eventually something will just fail, detach, short, anything. So this is great. So I'd imagine the first test I'd like to do is to remove the RAM and try and power up and see whether we get the error message as I'd expect. So no RAM, power on, 3, 2, 1, go. Yeah, we do have constant beeping, which is expected. So I don't really think the RAM is our problem, but it doesn't hurt to quickly check. Okay, the board is starting. Let me warm it up and see what happens once it's warm. And the board failed to post straight away, so no, the issue is obviously there. Right, I would say let me take a look at those components, but this is more and more a BGA problem with something. It could also be the PCB, some broken trace inside, so it's a big question mark. And I have a feeling that this is going to be unrepairable, because I think even if I were, and I'm not, a skilled BGA technician, we got plastic stuff here. We got the memory socket and we have the compact flash socket here at the back. I was planning to remove the capacitors to be on the safe side, but now I have plastic at the back. Yes, I can try and cover it up, but shut up, multimeter. Yes, I can try and cover it up, but I'm not sure it's going to work. But as it is right now, this board is not working, so there's not much to lose. I mean, if I break it, I break it. Now, the note bridge is behind here, exactly here, and I played with hot air and cold spray, and to be honest, I haven't really found like a smoking gun. I haven't found a single component that would immediately react to hot and cold. What I think I've noticed is that if I cool down and warm up the area just behind the note bridge, well, I can more or less consistently trigger it's posting, it's not posting. Let me show you. So the board should start right now because it's cold. 3, 2, 1, go. Yeah, it beeped, so it's posting, and I'm switching it off now. Got my hot air, low airflow, 250 degrees, and I'm going to warm up this area here, which is directly behind the note bridge. Just a few seconds, and let's try and turn it on now. 3, 2, 1, go. It's still starting actually. So it's power off again, and I'll warm up that area again. Okay, try again, 3, 2, 1, go. And now it's not starting. I didn't hear the beep, so it's off now. And I'm going to cool down just this area here. Okay, turn it on now. There you go, it started. So, I don't want to keep doing this. I've done it off camera, and it happens every single time. Now, what happens when I'm warming up the board? The board is slightly expanding. Any material which is warmed up, it depends on the material, it just expands naturally. And because I'm only warming up this area here and not the rest of the board, what happens is, well, the material is expanding. It doesn't have anywhere to go, so it warps. I made a short some time ago. Take a look. That's an extreme situation. I was running 500 degrees on my hot air station, but it gives you an idea what happens. Now, there might be a micro crack somewhere. It could be in the BGA solder balls, it could be in the PCB traces, it could be on the pad, it could be inside the chip itself. And by warping the PCB ever so slightly, we are triggering this breakage, and it will make or not make contact, and we see this behavior of I'm posting, I'm not posting. Now, the usual suspect when these things happen is the solder balls. This is BGA, it's post-2000 lead-free solder balls. They tend to crack over time. We're talking about a minute crack, which again is being triggered by this minute amount of warping that is caused by heat. And I can only imagine this must be some sort of non-essential line, because once the system is working, it's working even when it's warmed up. So this might be, I don't know, the reset line maybe, or what could that be? That it's preventing the computer from posting, but it doesn't crash the computer when eventually I'd imagine that connection severs because of heat. So I see where this video is going. It's going through a reflow/reball. But before I even think of doing that, I'd like to take a look under the microscope. This is the area in question. Let me have a quick look with higher magnification and see if I notice something out of the ordinary. The only thing I'm seeing is this mark in here. I don't know what that is. It doesn't look like a crack. Let's see if it goes away with some IPA. It does not. It looks harmless, to be honest, but it's kind of suspicious. Now, is that a capacitor or an inductor? This is in between ground, I have 0 ohms here, and this 26 ohm rail. This is not a CPU, it's a node bridge, but finding very low impedances, very low resistance is kind of normal when you're dealing with computers, GPUs, CPUs, RAM, and that kind of stuff, so I'm not too concerned about that. So because there is ground on one end, this cannot be an inductor. That means this is a capacitor, and maybe that is nothing? I don't know. Now I'm using some light coming from the side of the component, someone would call it the anti-glare light, and I don't think this is broken. The mark on the right, top right, I just did it with my multimeter probe, so that is not our problem. I would say this is totally fine. I don't think that is our problem. So let me reflow everything just for completion, and then we'll test again and we'll see what happens. Alright, I have 0 expectations, but first thing first, let's make sure it still works. 3, 2, 1, go. Yep, still posting regularly. Now let's warm this up and see if anything has changed. And it's not posting anymore, so yeah, again, I had 0 expectations, but I had to try that before going with BGA. Well, what can I say? The next step is to reflow it, reflow/reball it. Now, I'm not good at either of those tasks, so I think I'll go with a reflow. I appreciate that reball is probably a more comprehensive process, but I think I have very little chances to do a good reflow, even less when it comes to a reball. What I'm mostly concerned about is popcorning, which is when pockets of moisture trapped in between layers, they basically generate steam, and the steam will delaminate the board, making the popcorn effect. Let me store this board into my dry box, then I'll bake it to try and get rid of all the moisture I can, and then I'll attempt a reflow and we'll see what happens. Here I am again, trying to reflow a BGA chip. To try and minimize the risks, the board spends a week in my dry box, where humidity is usually around 15%. Those are silica gel beads, they absorb moisture. Then I bake the board for a few hours at about 120 degrees Celsius in my preheater with a do-it-yourself hood. Finally, I remove the capacitors, they might not like being overheated. The goal here would be to warm up the whole board evenly, but because the RAM and compact flash sockets, I decided for the lesson of the two evils, and I cover those areas with kitchen foil. It's not great, as those ends of the boards are going to be considerably colder than the central part. I've been using a long and bendable thermocouple for sensing the PCB temperature, but the cheap one I purchased some time ago has somehow self-destructed, so I had to buy another one. Those are not very cheap, so I hope this lasts a bit longer. They seem to be much more accurate at sensing the PCB temperature than the spherical ones. The plan is to preheat the PCB to around 200 degrees Celsius and then slowly add heat from the top with my hot air station until the PCB reaches around 235 degrees. I forgot to point the camera at the hot air station display, so you'll have to trust me on that. I let the board soak at intermediate temperature up to about 150 degrees to make sure the heat is as uniform as possible, and then it's time to go with the final step of 200 degrees. 200 degrees measured on the top of the PCB is about 300 degrees being read by the preheater, as the thermocouple is close to the heating plates. At around 160 degrees I add flux to 3 edges of the chip. I learned that adding it all around the IC will create an air bubble inside, which will prevent flux from flowing everywhere. Shortly afterwards, it's time to start with hot air. This is where things are tricky. You want to be fast so not to damage anything, but not too fast so the lamination happens. With hot air eventually running at around 300 degrees, the PCB temperature slowly reaches 235 degrees, and I totally expect the lead-free solder to be molten and be able to nudge the chip. But no, everything around the chip is molten, but the chip is probably kept cooler by all the various power and ground planes which extend to the colder edges of the board. At 238 degrees, I decide to give up. I feel I'm about to cause heat damage, and I don't want to insist. However, I decided to nudge the chip one last time, and surprisingly it moved, showing that the solder was molten. How bizarre that it decided to melt after the hot air was removed. I didn't hear popcorny noise and I don't see obvious damage here, so I am mildly optimistic. It's now time to let the board cool and to clean it as much as possible with isopropyl alcohol and compressed air. I'm going to do a quick check for shorts on the coupling capacitors nearby the north bridge, so hopefully those are going to be the main rails. I'm touching the shell of the USB port, which we know is the ground connection, and one end of this capacitor is going to be ground. As long as I don't have another short on the other end, that's fine. I've got kilo ohms here, this is ground, and I've got 188 ohms, which is not that short, so that's totally fine. This is ground again. And I have 23 ohms, which it's a computer, so low impedances can be totally fine. Got 23 on this one as well. 189 on this one. And no, I don't see a dead short on any of those capacitors, so let's put the battery back, the RAM, let's power it up and see what happens. Power on, 3, 2, 1, go. Oh wow! There is a beep. Okay, so this is still working. Well, I haven't got a microphone. I got too excited. Well, this is still working. We don't have video outputs, but there's a beep. And we have more or less 300 milliamps, so it's still working. Now, is it still gonna work once the board is warmed up? Let's test it straight away. The board is nice and toasty. Let's turn it on. This is still working. Look at that. Wow. Even more toastiness to the board. Let's test it again. Would you look at that? It's working. Yay. All right, let me reassemble it. And I don't know, but I feel this is going to work. This is pretty toasty. We'll never get to this temperature. It's time to put this back together and confirm that it actually works in its own case. Before attaching the heatsink, let's run a quick test. Yes, it is working. Amazing. Wow, I'm so impressed. Right, let me reattach the heatsink, then I'll have to run it for like 45 minutes, and then power cycle it, and cross my fingers. Everything is working. Let me run it for half an hour, 45 minutes, and then we'll power cycle, and we'll see what happens. This has been on for about an hour, so this is the moment of truth. Will it post when it's hot? Let's turn it off. Let's give it 10 seconds. And back on. No. No, how is that even possible? How is that even possible? It was starting with hot air. Oh no. I was so optimistic that that was going to work. No. Really? Yeah, it just restarts after, I don't know, a couple of minutes. But no, it still doesn't work. I was not expecting this. I checked the footage. The North Bridge clearly reflowed. It was clearly floating. Well, I guess that's probably not our problem. It's a big question mark, and I'm not sure where to move from here. Right, I've been playing with this board a bit off camera. I was trying to find something. I was trying to also look for the reset line. I couldn't find where the reset line is coming from. Those are all BGA packages, so it's more or less impossible to probe things around. And I have a feeling that we are dealing with the damage on the PCB somewhere inside the PCB. Let me see if I can show you what I found. So I have the oscilloscope running and I'm probing, there's an SPI connector here. I'm not entirely sure what it is for. From there, I can monitor some sort of activity when I turn on the board. Now the board is cold, so it should turn on. And let's see what happens when I do that on a working board, when the board is posting and booting normally. So 3, 2, 1, go. And you see there is activity. And then there is more activity. Then it beeps. And then it more or less stays there. I think something else will come up at some point. Yeah, the bits and bobs, but I don't care about that. I care about what happens when I turn it on. And what I've noticed is that if I warm up the machine artificially, the board artificially, well, it will eventually work over a certain temperature. And that's why it was working before, because I warmed it up quite a lot. It actually works when it's really hot. It works when it's cold. It doesn't work in between. There is like some sort of temperature and it will stop posting when it's at the temperature, but it will not crash the software it's running, which is mind-blowing. Now, what I think I found is that if I try and flex the board a little bit in a specific position, a specific point, well, it will stop posting. And the moment I release that pressure, it will post again. Let me see if I can replicate it. So, and what I'm going to do, I think I'm going to try and push it here. So I'm holding the board at the edge and I'm pushing it here in the middle. So I'm bending it a little bit, not too much. 3, 2, 1, go. No, I think it's still working fine. Yeah, so off again. Let me try a slightly different point here. 3, 2, 1, go. No, still working. Okay, so let's try here. 3, 2, 1, go. Right, I couldn't really replicate the problem. Now I feel that when I was able to do that on off camera, it was because the board had reached the critical temperature and my flexing had nothing to do with that. It was just the board cooling down and warming up, maybe. What I'm noticing is that the board is getting really hot around this area. You won't be able to see from the camera, but it's kind of discolored a bit. This is the power supply section. There are those two inductors are getting really toasty. I guess that's totally normal. So I'd imagine this area of the PCB just lives at a very high temperature from day one, all its life. And also I believe that the heatsink is more or less covering this part. Those two capacitors, which are reading fine, but these are probably running at pretty high temperatures all their lives. So now I have a little question mark on the area. But now that the board has reached the critical temperature and it doesn't post anymore, well, let me see what happens when I'm monitoring that pin that I was showing you before. So 3, 2, 1, go. That's it. It doesn't do anything. Actually, it goes a little higher and it doesn't do anything. There's no activity whatsoever. And sometimes I've seen that there is a little activity, but that's it. Then it stops. Now, that was an example when you see some activity, but then it stops. So I don't know. I don't know what it means, to be honest. But yeah, that's different from the other times. I've also removed the BIOS chip and I saved a backup just because I was turning it on and off all the time. And at some point it seemed like it had completely died. I couldn't revive it anymore. And then eventually came back. And I thought that maybe I was going to corrupt the BIOS at some point. I haven't got a BIOS for this board. So I removed the board. I grabbed the BIOS with my programmer and I actually rewrote the BIOS on the chip in case the chip was a bit like temperamental, borderline. But that didn't change absolutely anything. Now, I'd love to see where the reset line is coming from, because as for my Focusrite, I have a feeling this is the reset line failing. But I couldn't really find where the reset line is coming from. I had a look at the Wimbund. The Wimbund chip is getting a reset input. But I think it's responsible for resetting something, but that's not where the main reset is coming from. I checked every single chip on the board using Google, AI, and I couldn't really find a chip which is responsible for just generating the reset line. Chances are the reset line is just a capacitor or maybe a timer somewhere, and it just happens after a number of milliseconds after the board has been powered on. Or maybe it's coming from the south bridge, maybe something with the north bridge. I don't really know. So it could be absolutely anything. And to be fair, this board is working. I mean, I could try and reflow the CPU and what I believe is the south bridge. The problem is, especially the south bridge is very close to where the compact flash reader is. So I have a feeling I'm going to damage the compact flash reader. I don't feel like probably removing it. On the other side, I have, well, I guess the CPU, maybe it's a bit more further away from the RAM. I'm not entirely sure because I've reflown this chip here. That was definitely reflown. I think if there was something under the CPU, it would have probably improved, maybe temporarily, but it would have improved. The fact that this hasn't improved at all, I don't know, it kind of tells me that the issue is not here because everything around here has been reflown. Every single chip. So either it's the south bridge or it's something completely different that I'm completely missing. I think the last two things I'd like to try, number one, I think I'd like to go ahead and resolder those chips with 1,000 little legs. I had checked those legs under the microscope. They look fine, but if there's something on this board, it's a very, very small micro crack, which is going to be absolutely invisible by naked eye. So I'm going to reflow the Wimbund, and I'm also going to reflow, there's an ICS chip in there, which should be the clock chip. And then if that still doesn't work, I might spend a little bit of time on the ICS chip, try and identify what kind of clocks are coming out of it, which pins, and then let it warm up, let it stop, and then check again those clocks and see if by any chance maybe it's the ICS chip which got defective. What I cannot check is whether those clocks are reaching the relevant chips. Everything is BGA, everything is hidden under chips, and there's not much I can do about that. So let me go ahead and just resolder all those little legs and see if that changes anything. I really doubt it, but it's something I'd like to try. Now, this is the ICS chip, and I remembered why I didn't do this test before, is that I can't possibly find the datasheet of this. This is a 9LP505-2HGLF. So my only option was to go through the pins when the board is in a good working state, check what happens, take some notes, and then eventually try again when the board is failing to boot, to post actually, and see if I could see any different. What I found is this: the board is now running and it's in a working state. And I found that pin number 3, I call it 3, this pin here, this has a 14 megahertz clock, which I'd imagine is coming from the crystal. Maybe is that a 14 megahertz crystal as a reference? So we have 14 megahertz here. Then we have it on this pin here, I think. Yeah, it's a bit smaller, but it's still 14 megahertz. And then on the next one, I think, yeah, there we go, 14 megahertz. I couldn't find any clocks anywhere here, which is a bit weird, but without the datasheet, it's difficult to ascertain. Now, on this pin, I found this. Now, each division is 500 millivolts. I mean, I'm not sure whether this is supposed to be like this. This is not noise. I mean, if I'm going to a different pin, I don't have that noise. I'm not sure what this could possibly be, but it's there. And by the way, yes, there is a crystal here, which is outputting 14.3 megahertz. So this is clearly the input, the reference clock for the chip itself. I have turned the board around for ease of probing, and on this pin here, I'm reading 33 megahertz. I don't know what that is for. Is that for the RAM? Is that for the CPU? Is that for the PCI bus? And I see 33 megahertz on a number of pins, like this one, this one, this one, this one, this one, but on this one I have 48 megahertz, which is the USB clock. And that's it. I don't have anything else out of this chip, which is kind of weird. Now, let me put the board into a non-working state, and let's see whether we have those clocks coming out of the chip, and most importantly, the one going in as a reference. Well, that didn't take much. I just had to restart the board and it's now in a non-working state. Do we have 14 megahertz here? Well, we do have it at the clock. Do we have it at the chip? Yeah, we have 14 megahertz here. We have 14 megahertz here and 14 megahertz here. So this is exactly, maybe the next one as well. No, it was only this once. This is exactly as it was before. Now, do we have 33 megahertz on this pin here? We do 33, and there will be a number of other pins with 33, which is this one. Then we have this one. Then we have, yeah, pin number 5, or at least I call it 5. Then we have it here. Then we have it here, and I think that was it. Yes. And then finally, we should have the 48. Where is it? Here. That's it. That's my 48 megahertz. And that's it. This is, unfortunately, what I can see. It hasn't changed. It doesn't change in between working and non-working state. So next step, I'd like to take a look at the reset line on the Winbone chip. Now, if I'm looking at the Winbone chip, I found that pin number 30, which is this one, where the solder mask is missing, is the reset line, and it's labeled as an input signal. So maybe that's the general board reset line that I can try and monitor to see whether something happens in between the working, non-working situation. I'm in roll mode. Let's turn it on. 3, 2, 1, go. The board is on, and well, if this is a reset line, that would be active when it's low. So I think what we're seeing here is just that well, obviously the reset line starts from 0 volts because there's no power to the board. And I'd imagine the moment I turn it on, it stays low for a little bit while everything gets alive, and then it goes high only when everything is ready to start. So we don't see the reset line going low and then back high because it starts from low. So this is probably the expected behavior. Let's try one more time. 3, 2, 1, go. And it goes high. Then it beeps and it's happy. Now let me let the board reach that weird temperature, and we'll try again once the board doesn't start anymore. 3, 2, 1, go. And the board is not starting, and well, I don't see any difference here. It seems to be working, as in it's not stuck low, but the board is still not starting. Oh, that is very interesting. So the board is not starting, but I've noticed like a momentary reset of the board because the signal, assuming this is a reset line, the signal went to 0 volts, so went low for a moment and then back high, as if something was noticing that something is not working and try to reset the board again. This is quite interesting, and from what I can see, it doesn't happen every time the board is not starting, which is even more puzzling and interesting. And this is where, unfortunately, I have to stop, because I don't really know where else to look at this problem, and I would appreciate your input. If you can think of something, I should check, please do let me know, but it looks like something which is pretty much impossible to diagnose. I don't want to do crazy things to this board because it is working. Once it started, it doesn't stop. I ran memtest on this board for many hours. It went really hot. And it was still working, not a single error, no issues whatsoever, but then you restart it and it might not start. Again, it needs to be at a specific temperature apparently, so I can't possibly think what it could be, but it could be absolutely anything from a faulty chip and or a faulty PCB itself. So once reassembled, this can be used. It's just like my Focusrite interface. Whoever is using it, they need to remember that they can't power cycle it when it's at working temperature. It has to be cold, then it starts, and it works for as long as you can think of. But I'd love to hear from you if you have any ideas what to do next. to fully revive this board and make it fully functional. So I guess that's it for today. I hope you enjoyed the video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon. The links are down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to join me on Patreon, well, maybe you can buy me a coffee. And the link is also down below in the description. If you don't want to buy me a coffee, well, that's totally fine, and I hope you enjoyed the video. That's it for today. Thank you for watching. I hope you have a great day, and I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye bye.